Okay, so next would be standard normal variable. So what is we have talked standard. So standard normal variable. So this video will just we know that when for a standard normal distribution the mean is 0 and the standard deviation is 1, and we're gonna try to describe how we come up with this. So we know that the expected value for a continuous variable is given by expected value of a any variable, continuous variable, is given by integrating from minus infinity to plus infinity fx dx. Actually it is going to be x into fx dx. So using that to calculate the expected value of a standard normal variable, we're gonna get minus infinity to infinity z, and then the phi z, which is the PDF of it, and dx, which is just going to be minus infinity to plus infinity z e minus z square upon 2 multiplied by 1 upon under root 2 pi, which is nothing but the PDF of the standard normal variable dx dz. So now here is some calculus law which says that this is an odd function and this is going to be 0. We're not going to go into that, but if we solve this using some advanced calculus, you get a value of 0, and that is by expected value of z, which is the mean of z, is going to be 0. Now and this is also you can think of it as um, by logic. If all the values are symmetrically distributed around 0, on an average the value will lie around 0, or expected value is going to be 0. Now how do we calculate the variance of a of any variable? Variance of z is going to be expected value of z square minus expected value of z square, and we know that expected value of z is 0, so that goes away. So all you have to calculate is expected value of z square, and that is going to be just an integration minus infinity to infinity, and that you have to now use this little equation here and square it. So that will become e to the power minus z square by 2 z square into minus z square into 2 multiplied by 1 upon under root 2 pi. Now since there is a z square here, by some rule of calculus, the fx doesn't get, so fx is the same, it is the z square which is here. To calculate this as z square and integration and a dx and a dz. So by some rule of calculus this will come out to be 1, so that is why, and that is the expected, that's the variance of z, which is basically sigma square. So for standard normal variable the mean is 0 and standard deviation is sigma square, or sigma square, or sorry, sigma square, which is the standard deviation, is 1, or this is the variance, which is 1, which is the sigma square is 1. So now what, so that's the standard normal distribution, but what is the general normal variable, general random normal variable? So here we will define this general distribution, general random variable as x, which we will define as sigma z plus mu. And this is similar to this is how we come up with this familiar computation of z of, so if this is how we define x, then what is z going to be? So minus z, so x is equal to sigma z plus mu. That means sigma z is going to be x minus mu. That means z is equal to x minus mu upon sigma, and that is the familiar way how we convert any general normal variable into standard normal variable. And we have the tables and applets for this, but not for the regular or general normal variable. So we describe z as normal 0 and 1, which is 0 is the mean and this is the variance, not the standard deviation, variance, and x, which is the general normal variable, will be described as n with a mean of mu and sigma square. So this is the connection between the standard normal variable and the normal variable. Now we're going to solve some questions for this, and I think that's so question is, the distance in meters covered by a athlete in his jumps has normal distribution. So athlete jumps and the distance has a normal distribution, and if it has a normal distribution, so it has a mean of 6.5 and a standard deviation of 0.5. Now we want to know the probability that this athlete will cross 8 meters in a particular jump. So again, for this we just draw this probability distribution and we say, okay, we have a mean of 6.5 and a standard deviation of 0.5, and we want to know here, which is 8. We want to know the area here, but how do I calculate the area here? To calculate the area here, I need to convert this into a standard normal variable, which is going to be z, which is going to be 8 minus mu upon sigma, which is going to be 8 minus 6.5 upon sigma, which is going to be 3. So now we know that this is the z of this is 3, and we want to know this. So phi of 3 is just going to give me this area, but this is not the area we want. We want to know this area, but by symmetry this area is going to be similar to this area over here. So this phi 3 or 1, and what is that area? That area is nothing but 1 minus phi 3. This is the area we want, 1 minus phi 3. But 1 minus phi 3, which is this area, is equivalent to this area over here, which is phi of minus 3. So that's the answer. It can be this also, but for this particular question the answer is phi of minus 3, which is correct. Some more questions. One question is, question is use distribution tables to evaluate the probability that a normal random variable with mean of 22 and a variance of 4 takes a value smaller than 19. So first thing, we have this distribution. Here is the mean is 22 and standard deviation is 2, and we want to know that it takes a value less than 19. We want to calculate the probability of this area here. So first thing, again we have to do is to convert this 19 into a standard is the z value. So z value of 19 is going to be 19 minus 22 upon 2, that is going to be 1.5. Now all we have to do is to calculate the area to the left of minus 1.5, and then we can get it from an applet of 0.0668. The next question is, what is the threshold such that probability that a normal variable with mean of mu and variance of sigma square is greater than or equal to p. Now what are they actually trying to ask here? What they are asking is that we have a normal distribution here which has a mu and sigma square, and we have a normal variable here, and this is the greater than or equal to p. This is the p, and this, the variable is here is a, which is going to be a minus mu upon sigma. So that is the variable, but what is it going to be? Z of a. Now here is something that we need to know. If f of x is equal to y, then x is going to be f minus 1 y. This is also a rule in mathematics of function, that if function of x is y, then x is going to be f minus 1 y. So we're going to use this rule now. So probability is going to be 1 minus, probability is going to be 1 minus probability of this area here is going to be 1 minus phi z of a, which is the CDF of a, which is this whole thing will represent the area here, which we are not interested. So we are interested in this area here. So that's what it is. Now so what is then minus phi, which is capital Phi, minus phi z of a is going to be p minus 1. So phi z of a is going to be 1 minus p. But here is, we're going to apply this principle, which is f of x is equal to y, then x is equal to f minus 1 y. So we want to know z of a then, and remove this function variable here. It's just going to go on the other side, and it's going to become negative phi 1 minus p. Now we also know that x can be described as sigma z plus mu. So in that case, we want to know a is just then going to be sigma and sigma phi minus 1 minus p plus mu, which is going to be your answer, because we're gonna just input this over here, and that's just going to be the answer. Okay, next question is that we want to evaluate the threshold which in normal variable with a mean of 22 and a variance of 4 can exceed with a probability of 0.1. So now we're gonna again draw this standard graph over here, and we'll say okay, so mean is 22 and we have this threshold which is t, and the area outside it is 0.1. So now we know that the CDF of ZT is 0.9 because that is going to be this whole area here, that is 0.9. So we can put this in an applet and we can calculate the value of Z for an area of 0.9, which will come out to be 1.282. Then we can calculate the value of A using the equation A is equal to negative Z plus or sigma Z plus mu. We can calculate because we know the sigma as 2 and the Z value we got 1.282, and we add the mu which is 22 and we get the number of 24.564. So the trick is to be able to calculate the value of Z